Hey guys, are you looking to amp up your SAT score? In this video, I'm going to show you some super shortcuts for the SAT math section. And I scored perfectly on the thing as an adult. I've coached so many students to perfect scores in this particular section, and I would love to help you do that too. I'm going to give you tips here. I definitely recommend that you check out our super seminars. We've got some coming up about a week and a half before the SAT, moving into the weekend before the SAT. Those are for students who are aiming for 750 plus on each section of the SAT. Thumbs up if that's you, overachievers. Okay, so first question here, we're going to learn the ratio shortcut. This is basically the idea that the ratio of sides and areas and volumes can be calculated between each other really quickly and easily. For example, if I know the ratio of the sides of a square, I'm going to draw out a couple of squares right here, right? And I have a small square and a big square. And let's say the small square is X side length and the big square is Y side length. If I know the ratio of the side lengths, I can very easily find the ratio of the area by simply squaring the ratio of the side lengths, okay? And then I can find the ratio of the volume of something with these side lengths. Let's turn these into cubes, everybody, right? By cubing the side lengths. So this is the pattern, right? If I know the side length ratio, I square it to get the area ratio. If I know the side length ratio, I cube it to get the volume ratio. This also, by the way, works with surface area or area of a particular corresponding surface if I have a three-dimensional figure. But that's the basic pattern. Super simple, super easy. We're going to look at it in action on a couple of problems. This first one, we don't actually have to use it to be as fast as possible. This one, you can be fast in a couple of different ways, but it's still kind of a fun thing to know. So we have ABCD is twice the side length of EFGH. So I'll make this EFGH. I'll make this ABCD. Okay, so this is the big one. This is the small one. The area of EFGH is 9. So this is 9. What is the area of this? So I could do this the slow way. The slow way is that I'm going to take the square root of 9, and that makes this 3 and this 3. I know that this is twice the side length, so that makes this 6 and this 6, and so that's 36. Maybe that's not actually the slow way on this one, because that was actually pretty fast, but it's the old-fashioned way. Now I'm going to show you the shortcut way, okay? So if I have EFGH is 9, right? And I know that ABCD is twice the side length. So I know the ratio of the sides is 1 to 2. All I do is I take that ratio of the sides and I square it, right? And I get 1 to 4. So I know 1 to 4 is the area ratio, and this is just small over big. So I know that this is the small one, right? So I'll erase my 36 from my earlier math over here. Boom, boom. Right? If that's my small one, then to get to my big one, I just have to put small over big. So I put a 9 over here. And we get 1 over 4 equals 9 over b. I cross multiply, I get 36 equals b area, and I'm done, okay? So that's how we do it with the ratios. Again, on this problem, it was probably just as easy to do it the old-fashioned way, but on this next problem, you're gonna see that, wow, this is gonna come in really handy. Here we have 2 boxes, okay? One is a big box, and it has a volume of 96, and the other is a smaller box, and it has a volume of 12. Remember, a rectangular prism is just really fancy for like a shoebox shape rectangular box. So we have these similar shapes. The table gives the volumes. The length of the longest side of prism A is 6, so that means like this is 6, and then we want to know what is this side length. I just called it n over here. So what I know is 6 over n is big over small side length, right? So remember, if I take the side length ratio and I square it, I will get the area. But here I don't want to square it. What do I want to do? This is volume. I want to cube it. So one way I can do this is I can take this cubed, and that's going to equal, this is the big one, so big over small. And the biggest thing, like I said, you have to keep track of big over small. So I get this, and now to simplify, I might take the cube root of both sides, because I don't know that I want to cube 6. That might get ugly. I guess I could do it that way too, but I'm just going to take the cube root of both sides. So 96 over 12 actually simplifies to 8 over 1. You can do that in your calculator if it's the calculator section, or you can keep dividing by 2 until you get down to it if it's the no calc and you don't know that off heart. And over here, I'm going to cube root this, and then I just get 6 over n. So 96 over 12 is just 8 over 1. So I'm going to take the cube root of 8 over 1. So the cube root of 8 is just 2, because 2 times itself 3 times is 8, right? So I get 6 over n equals 2 over 1, and I just cross multiply, and I get 6 equals 2n, and I get 3 equals n. And I'm done. So the thing about this one the length here is going to be 3, right? Because this is like a 1-to-2 ratio. The thing about this one is like, if you didn't have this idea, it gets a little nappy because I'm not going to know exactly which side this is, right? On the square one that I did above, I could figure out each side length, but here I only know one of the 3 sides. So understanding this ratio thing is going to be really clutch to getting this right, okay? And it's just fast and easy, so it's a good one to know. Okay, next super shortcut is a graph shortcut, and that's basically use the graph, you guys. Trust the graph in the SAT. Now, when I say trust the graph, make sure you look at the labels. Labels are super important. But you see, this is a really ugly system. It's a quadratic and an exponential function. Man, I do not want to dig into that hardcore. So you can see there's basically 2 points here. One looks like it's about 2,6. Okay, so I'm going to write down 2,6. This one looks like it's about 5, maybe 4.5. So I'm going to look for these 2 points down here and see what's close. This is obviously the 2,6 reversed. 4 is going to be out. It's either going to be this one or this one. I'm going to go here to 4.5 and kind of like dig up. And I'm pretty sure that's not the point. So I'm going to go with the 2,6 and call it a day. I'm going to put 2 check marks next to it. And what do I do at the end if I have time? Well, if I have time, yes, I'm going to do it algebraically. But rather than do it algebraically, I mean, you guys, this is a mess. Do you really think I'm going to like solve for x up here? Like, this is a quadratic. Like, how are you going to solve for x and then plug in, right? Or I could set the 2 y's equal to each other. But you guys, that is so fugly ugly. Like, you do not want to mess with that algebraically. So just use the graph, especially the farther you are away from linear equations, the more I recommend using graphs. The closer you are to linear equations, sometimes the algebra is faster and better, okay? But if these are nonlinear equations, graphs are there, use them. And even if they don't give you the graph and you have a system, sometimes I will sketch it out, and the sketch is also going to help me out. Because if you have vertex form, for example, in a parabola, it's really easy to sketch that out. Draw a little sketch. Drawing stuff out can really help you, especially if they're looking for any graph behavior or stuff like that. If I did want to double check this at the end, what I would do is I would just come back with the point 2,6, and I would plug it into both of these equations and just make sure that it's correct. So I'm going to do that really quickly. So we have y equals -4 times 2 minus 3 quantity squared plus 10. And the y, of course, is 6. So I actually can erase the y. That's 6 equals this. And that's -1. -1 squared is +1. So this just goes away. And I get -4 plus 10 equals 6. And 10 minus 4 is 6. So 6 equals 6. That's true. Check. Right? And then I can do it again with this. So this is 1/2 to the 2 minus 3 plus 4, and this again should equal 6. So 2 minus 3 is the -1 power. So what's the -1 power? Well, that means that if, right, n to the -1 equals 1 over n to the 1. So it means take the reciprocal, yeah? So all I have to do here, because it's a 1, is just take the reciprocal of 1/2. The reciprocal of 1/2 is 2. 2 plus 4 is 6, and that's correct. And so check, I'm done. Both of these checked out. It's going to be 2,6. And then I can move on. Again, I don't do this double checking probably till the end, but I put a check mark next to it, and that double check mark is my symbol to do that. But it helps me have this shortcut so that I can whip through the test. Last tip is I like to make exponent 0. Whenever you have like exponential questions, sometimes a good technique is if I make this 0, this whole thing becomes 1, and then the whole thing goes away. So I know, for example, really fast that 0, 2 is going to be on this graph. So 0, 2, I know that's in the game. I know this is out. So I can eliminate answers really quickly with this. That's the only one I can eliminate here. On this question, I'm actually going to be able to get all the way to the answer from this trick. So here I have this equation graph, but I don't know what the a is and I need to figure it out. So the best way to do this is just to pluck points. And again, what's my favorite point to check is x equals 0. And plugging that in, because when the x equals 0, it's going to zero this out. Now, sometimes I don't pick x equals 0. I pick whatever makes the exponent 0. So if this were x minus 3, in fact, I might pick a 3, and then this whole thing becomes 0 because anything to the 0 power equals 1. And that's usually a really easy number to work with algebraically. So I'm just trying to make the algebra easier. If I create a 1 somewhere in my equation, that should make my life a little easier. It's a really easy number to deal with. Doesn't mean you can't pluck other points. I can make a t-chart here, x, y, and I could pluck several points, right? We have 0, -3. We have over 2, up 0. I have maybe even 3, 4. So if I don't get enough information off the first point, and it does take more than one point to define an exponential growth equation, I might have to plug in another point, but typically it's going to work in maybe even just one. So the 0, negative 3, I'm going to plug in here. We get 2 to the 0 minus a equals negative 3. So this is just 1 minus a equals negative 3. I can subtract 1 from both sides. I get negative a equals negative 4. Well, that means positive a equals positive 4. And that's answer choice A, and I'm done. Hurrah, huzzah! So there you go, you guys. There are some cool shortcuts to recap them. The first one is the ratio shortcut. Remember, if you have the side ratios, square them to get the area ratios, cube them to get the volume ratios. Second tip is with graphs. Trust your graphs. Go to the graph, use the answer choices, and just shortcut by plucking points off there. Third tip is if you have exponential graphs or exponential equations, try to figure out how to make that exponent into 0, and then that whole thing will turn into a 1. And that's sometimes like a little clever trick to work through exponent problems quickly and easily. Thanks so much for watching, you guys. We've also got private tutoring and a full online course for the SAT that's over 800 hours of me working problems. So if you are ready to dig into this, you have the self-study bug, and you want to hit this out of the park. We've had people score in the 99th percentile on the SAT, get into places like Harvard because of the SAT score that our course helped them get. So we would love that to be you too. Check it out, SupertutorTV.com. There's going to be more stuff in the blog that goes with this video, so make sure you check out the blog. You can find the link to that in the description. Thanks so much for watching, guys. Subscribe to our channel if you haven't yet, and check us out on social. We're on TikTok, Facebook, Instagram, and Twitter. I will see you there. Go crush your SAT. Thanks for watching, and we'll see you soon.